AI and machine learning, and we're going to do an introduction to machine learning today. So for your warm-up journal, what is an example of AI either in your personal life or that you've seen in a movie or a book? So pause the video here so that you can answer this question. And once you have completed this journal, go ahead and come on back. AI, or artificial intelligence, is used in a lot of different places in our lives, from facial recognition on your phone or to personal recommendations when we browse the web, and even in driverless cars. For the next little while, next couple of weeks, we're going to focus on a specific type of artificial intelligence called machine learning. What is machine learning? Well, let's watch.
My name is Ali Flores, and I'm a product manager at Alexa.
My name is Dr. Chelsea Haupt. I work at the Allen Institute for Artificial Intelligence, and I work on an AI-powered academic search engine. All around you, computers are making decisions, and those decisions affect your daily life. When you do an internet search or scroll through your newsfeed, computers decide what you see. Computers can already recognize your face and understand your voice, and soon they'll be driving cars and detecting diseases even better than humans. So how is any of this possible?
You may have heard about something called AI, or artificial intelligence. True artificial intelligence is decades away. There's a type of AI called machine learning that is here today. It's a type of AI you probably interact with every day without even knowing it. And it has the opportunity to help us tackle some of the world's biggest challenges.
Machine learning is how computers recognize patterns and make decisions without being explicitly programmed. What's so exciting is that it's a completely different way to program a computer than what we've ever done before. With machine learning, instead of programming a computer step by step, you can program a computer to learn just like you learn, through trial and error and lots of practice.
Learning comes from experience, and that's true for machine learning too. In this case, experience means lots and lots of data. Machine learning can take in any kind of data: images, video, audio, or text, and begin to recognize patterns in that data. Once it learns to recognize patterns in the data, it can also learn to make predictions based on those patterns, like noticing the difference between an image of a car and an image of a bicycle.
AI and machine learning are playing a bigger and bigger role in society at large and shaping all of our futures. That's why it's so important to learn how it works with some hands-on experience. You're about to get the chance to train your own machine learning model. Remember, AI is like any tool. First you get the knowledge, then you get the power.
All right, so our key vocabulary for this lesson is machine learning, and it is how computers recognize patterns and make decisions without being explicitly programmed. So by the end of this lesson, you will need to add this vocabulary to your journal, okay? Machine learning helps us solve important problems in society. And so as we cover this unit, we will look into how to create our own machine learning apps to solve problems. To help accomplish our goals, we will use the problem-solving process that we learned about in Unit 3. define, prepare, try, reflect, and always empathize. Let's take a look at how some of these steps appear for machine learning in particular. So you have, for the define step, what problem are you trying to solve? Prepare, what data do you want to use? Try, let's train a model and test it out. Reflect, how well did the model do? How can it be improved? And that will make more sense as we get to the training the model part, okay? What is the impact on society? Who is included? Who is excluded? That is the empathize part, and that will also make more sense as we go throughout this unit, okay? So our question of the day is, how can we use the problem-solving process to help solve a problem with machine learning? So in today's activity, we're going to use machine learning to help a robot clean up the ocean and learn how to identify fish. We'll give lots of examples of fish, give it time to learn from those examples, and then see how well it does in cleaning up the ocean. So what you need to do now is download your activity guide and get something to write with, like maybe your finger, I don't know, depending on what you are doing, what you are using. If you have something to write on your screen with, you can do that. Okay. Then we will go to Code Studio. This is linked in your assignment post, and it is Lesson 1, Level 1, Recognizing Fish. Okay. So let us look at this. Okay, so Level 1, Lesson 1, Bubble 1. Garbage dumped in the water affects marine life. In this activity, you will program or train AI, artificial intelligence, to identify fish or trash. Let's clean up the ocean. Click anywhere on the screen to continue. Let's meet AI. AI does not know if an object is a fish or trash, but it can process images and identify patterns. To program AI, use the buttons to label an image as fish or not fish. The training you provide will teach AI to recognize patterns on its own. Let's get started. All right, and then you're just going to do this for how long? So you'll just do it. Okay, did you know 17 billion pounds of plastic enter the ocean each year? No, I did not. You are programming or training AI with each click. Keep going. All right? Did you know 80% of ocean pollution comes from land debris and is estimated to cost $13 billion per year? Did not. AI learns from your choices. If you make wrong choices, AI will repeat your mistakes, so keep training. So this right here, this question we are asking, is this a fish? You have two options like what you see right here. It's either yes or no. And what we learned from an earlier unit is that this is a type of Boolean question. So I want you to think about how we used Booleans and how that code might look. Great work. The more data you provide AI, the more it learns. Keep training AI or continue when ready. So once you get to 30, I want you to go ahead and click continue and move on. Now let's see if AI knows what a fish looks like. AI will analyze a random set of objects and label them based on your training. Let's go! Let's see how good I did. Not a fish, not a fish. A tire got through. Oh no, tires keep getting through. Okay. So now an apple core got through. Alright, after you see that some trash is still getting through, go ahead and click continue. A broken light bulb got through. So if we wanted AI bot, hold on. So based on your training, here are some objects that AI identified as fish. How did AI do? Okay, well, considering that AI said tires and apple cores were fish, I would say no. Okay, so if we wanted AI bot to become better at recognizing fish, how do you think we could help it do that? Train more. Click here to switch between objects identified as fish and not fish. That's okay, we're good. Now we need to train it more. That way, we have a greater accuracy. So we are, as you can see, we are adding on to the number that we had earlier. Okay. And we want to make sure we get tires in there as not fish because that's what mine was recognizing. So we want to make sure that we take care of that. I wish I could see a light bulb coming across here since it also thought a light bulb was a fish, because that would help. All right. Oh, there we go. Okay, let's say once you get to 75, you go ahead and click continue. Okay, and run your AI to test and see. Oh, the apple core still got through. I guess technically an apple core would not be that big of an issue since it is food. It will degrade over time. It is still garbage though. Ah, the light bulb got through. Okay, I'm gonna pause it. And we're going to go ahead and hit continue because we know that that AI model is not 100% accurate, but we're going to move on anyways. Okay, so we could train more or we could hit continue. So let's go ahead and go on to level 2. The example, so training this AI with fish or not fish is one example of how problem-solving process and machine learning can be used to solve a problem. We prepared our data, we used it to train the AI, then reflected on the results. What was a fish? What was not a fish? What did it count as a fish? That really wasn't. So we decided what to do next based on that information. Ideally, we would want to keep training that model until it was 100% accurate, or at least 99%. So in this next level, in level 2, we are going to follow this process, this problem-solving process, and train the AI bot to detect certain kinds of fish, like redfish or bluefish or triangle fish. Okay. Go ahead and go to Pause the video here if you need to finish bubble 1 and then come back for bubble 2, okay? Choose a word that you want AI bot to detect. I'm going to go with blue. So now we're still asking a yes or no question. So this would be a Boolean answer, and I'm looking for blue. Do you think AI has enough training data? You can click continue to find out. I'm going to hit, since that one's blue. Okay, let's hit continue. With your training data, you have programmed AI to recognize a blue fish. Let's see AI identify blue fish. Okay, let me hit run. Since there are only maybe 3 or 4 colors, it should be pretty easy. Blue. Oh no! Wait, were those blue or purple? Okay, well, it is not perfect. It's not even good. So I think let's train it some more because we need it to be better. Click on the info button to see what AI learned. Okay, AI. These were the most important fish parts: colors, mouth, tail, body, eyes. Click on the individual fish to see their information. All right. This fish was blue or not blue? Okay. Let's train it more because now I'm kind of seeing that there's like a purple. And that's the purple right there. So light green, dark green, a yellow, a red. That's purple. That's blue. Blue. Great work. Keep training AI or continue when ready. Not blue. Not blue. Blue. Not blue. Blue. Not blue. Not blue. Not blue. Not blue. Not blue. Not blue. Because it's purple. Purple. Okay, and now I'm up to 75, so let's continue. And let's see if our model is a little more accurate this time. Purple, yellow, red, 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 green, yellow, yellow, purple, green, green, yellow, purple, blue. Yes. All right. So that's good. Some of you may notice that AI bot was learning about parts of fish that actually were not important, right? So right now, you can see this model has 100% accuracy. And if you click on it, it's learning, this is the stuff over here. It's learning about different parts of the fish that are not important, right? So this happens in real life too. Machines can learn patterns that we don't intend, even with lots of data, which can cause AI bots to make mistakes. For this situation, it's pretty easy to tell if AI bot made a mistake, and we can quickly see if a fish isn't actually the color or the category that we chose. So because I chose a color, I know I'm not looking for a specific shaped fish. So let's try a slightly harder challenge, trying to recognize the fish's expressions. So once you have a really good accuracy, click continue and let's move on to bubble 3. Pause the video if you need to finish up bubble 2. So I want you to, for bubble 3, I want you to choose an expression. Okay. And let's teach AI that word depending on what we think it looks like. So, these are really kind of, happy, you know what happy looks like. Angry, okay, you know what angry looks like. Fast, what expression would show fast? Silly, we could kind of pick one that looks like silly. I'm going to go with glitchy. So it's going to be up to me to pick the fish that matches the word glitchy. It's fair. Is it fair to use artificial intelligence to judge a fish by its looks? While AI might seem fair and neutral, its analysis comes from the training we provide. What unintended bias could this cause? And as we go throughout this unit, you're going to find out a lot about unintended bias. Okay, so what do I define as glitchy? When the face is not completely on the fish, I consider that to be glitchy. All right, and like this smile, this upside down smile, and the eyes are too big, and the mouth is not even on the fish. That's what I consider to be glitchy. You might consider something else to be glitchy. So the fact that I'm programming this based on what I think is glitchy could be an issue. Okay, I've got 25 pictures in. With your training data, you have programmed AI to recognize glitchy fish. Let's see AI identify glitchy fish. Go ahead and run it. Okay, so based on the training, AI identified these fish as glitchy. How did AI do? You can train more if you want to improve the results. Or you could teach AI a new word by choosing new word. So, yeah, glitchy, no. Yeah, glitchy, maybe. Yeah, glitchy, yeah, maybe. Yes, 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 no. This is not glitchy. Okay, so let's move on. So what you're going to do now is you are going to move on to Bubble 4, and this is a quick check to see what all you understood about this lesson. And one last thing is that even with a small example of judging a fish based on its expression, we see that machine learning can get into trouble and learn something that's harmful to a particular type of fish. Having more data and making sure it represents all types of fish can help solve this problem. And these types of examples happen in the real world too. And they can have serious consequences, such as whether or not you receive medical care or get a job offer. Throughout this unit, you will learn how to use machine learning to solve problems, but we also need to always be thinking about what is the impact and who is being included or excluded. So pause the video here and do the Bubble 4, understanding the check-in, okay? And then complete the wrap-up journal and add the new vocab to your journal also.